Today's topic is nature of the quadratic form. Actually, we have two methods to find out the nature of the quadratic form. This is without reducing to canonical form. Okay, we need not reduce to canonical form for a small problem. So, how to find the nature? So, what is the condition means we need to find for the D1. D1 is nothing but A11, the first element. In the given matrix, the first element is called D1. D2, 2 cross 2 matrices A11, A12, A21 and A22, the determinant format, one answer you will get. D3 is determinant of A, we have to find it. Using these three values, we can decide whether which nature it is. We have 5 conditions for the nature. The first condition is when all the value D1, D2 and D3, when all the values if I have positive, then it is called as the positive definite. Okay. Second case, when all the three values are positive, any one of your di equal to 0. What do you mean by that means? So any particular, it will problem to problem, it will be changing on. Suppose if I get D1 0, D2 and D3 should be positive. Then it is called as a positive semi-definite. Okay, semi where we use means when you get 0 only, we'll be using semi. Okay, semi when you get means any one parameter. Okay, D1 or D2 or D3, any one you get 0, we have to decide whether it is positive or negative semi-definite. You have to decide it. Okay. So when other than any one data, other than the two values are positive, it is called as positive semi-definite. Third case is when D1 and D3 are negative, in between D2 is positive, it's called as a negative definite. Same way, fourth condition, same D1 and D3 are negative, D2 is positive, and any one Di, it may be 0. Okay, in that case, you will be getting a negative semi-definite. Okay, what are all the possibility you can get it? Example, for example, suppose D1 I am getting to be some -1, D2 I am getting to be 0, okay, D3 I am getting to be -4. Okay, so in this what it is? Okay, don't tell it is a negative definite because 0 you got in a D2. Okay, so it is a fourth case negative semi-definite only. So other case it can be suppose D1 equal to 0, D2 I will be getting some positive 2. Okay, so D3 if I am getting some negative -2, it is also negative semi-definite. Suppose I will give you one more example also. D1 I am getting to be -1. D2 I am getting to be some 2. But D3 0. If I got, it is also negative semi-definite only. So other than all the 4 cases, first one by one you have to check it. Other than these 4 cases, all other cases is called as a indefinite. So this only we are going to see in some problems. So the first problem, find the nature of the quadratic form. So it has been given in the question, find the nature of the quadratic form. So we need not convert to canonical form. Already it is in the canonical form only, the final answer, whatever we write in the final answer. So that case only it is there, x1 square plus 2 x2 square. But left hand side you check, it is a 3 variable, but one more variable is not there. So it is the meaning one of the variable x3 equal to 0. Okay, then only I can write like this. So one of my parameters are 0, the other twos are positive. So what it is? One of the parameter is 0, other twos are positive is called as the positive semi-definite. Directly without doing anything, D1, D2, anything I did not do. So with seeing the question itself, we can find out also some cases of the problems. Okay, it's called as a positive semi-definite because we know that one D1 it's nothing but so first element, two elements are positive. So that is why we are writing positive semi-definite. Okay, next case. Second problem, find the nature of the quadratic form whose matrices are given. Now it is in the form of matrix. So now you check. So it is upper triangular matrix or lower triangular matrix. So what do you mean by that? Upper triangular or lower triangular matrices means it is nothing but diagonal elements is your eigenvalue. Correct? diagonal elements will be your eigenvalues. So the eigenvalues are minus 1, minus 1, minus 2. So 3 eigenvalues. So we are getting, so all the 3's are negative. All the 3 are negative means what it is? Negative definite. I did not find D1, D2 and D3. Instead of eigenvalue itself, I am saying same rule, whatever D1, D2 and D3, it carries for a eigenvalues also. Okay. So that is why here also I am saying it is using eigenvalues. Two eigenvalues are positive, one of the eigenvalues is 0. So it is positive semi-definite. Same way here. Okay. But third case, it is given in the quadratic form. Okay. Discuss the nature of the quadratic form. So first we need to convert it with respect to the given matrix A. Then only decide whether which type it is, which nature it is. First we convert it. So the how we have to convert it. The diagonal elements are the x1 square and x2 square is that okay 2 z f2 to 2 z 1 minute. I will change the question. 2 z I left out when I write it. Question is 2z 2z square plus 2xy. Okay, I change the question now. 2 is the square plus 2y. So now when I write the matrix format, it is 2, 3, 2. Okay. Xy is nothing but here. Okay. So it is nothing but half of the element 1. Remaining elements is not given in the question. Remaining elements we fill it with 0. So this is our given A matrices. Okay. From the given A matrices, okay, we can find out. Okay. So now this is the quadratic form, like given A matrices are quadratic form. So D1 you can calculate it from this. D1 is nothing but 2. Okay. D2 we need to calculate. D2 is nothing but first 2 cross 2 determinant 1, 3. So when I calculate 6 minus 1, 5. Same with D3 you calculate. D3 is nothing but the whole determinant. Whole determinant you can calculate it. If using a calculator you can calculate it. So I'm getting 10. So all the three values are positive. All three values D1, D2 and D3 are positive. So all the three values are positive means it is a positive definite. Problem 4. Problem 4 it is given to be same thing. Discuss the nature of the quadratic form. Quadratic form has been given. First I will write the given matrices. So matrix when I write it. So diagonal elements 1, 2, 3. So xy is nothing but half of the element 1. So y is nothing but here. So y is half of the element minus 1. X is half of the element minus 1. So fixed. So this is our A matrices. From this find out your D1. D1 is nothing but 1. D2 is nothing but first 1 cross 2 cross 2 matrices. So 2 minus 1 1. Okay, same way D3. D3 is nothing but determinant of A. Using a calculator, you can calculate it. Okay, so I am getting minus 2. So negative I am getting. Okay, you check with the first case. First case, what it is? Our first case, all are positive, positive definite. It is not first case. Second case means all should be positive, any one should be 0. It is also not there. Third case, it should be negative. 1 and 3 should be negative. It is not there. Third case also. Fourth case, any one should be 0 and other two should be negative. It is also not there. So it is a indefinite. So first 4 condition, it is not satisfied means it is a indefinite. Okay. Thank you.